Hi everyone. Today we're going to go over simplifying algebraic square roots. So basically what we did yesterday, but we're going to throw in some variables. So we got our first one here. It says the square root of 45a to the fifth. So to simplify this radical, we remember what we are going to break down 45 into its prime factorization. So we've got 9 times 5, which is 3 times 3. So I've got 3 squared times 5. And now I want to take a to the fifth, and I'm going to rewrite it as a squared times a. And then just like yesterday, I'm going to pull out anything that's a perfect square. So the square root of 3 squared is 3. The square root of a squared is a. The square root of a squared is a. So outside of the radical, I have 3a squared, because a times a is a squared. Under the radical, I have 5a. So this would be considered the simplified radical. Let's try it again. So radical 28, x to the seventh. So 28, I know I can break up into 4 times 7 and 2 times 2. So here are my factors here, my prime factorization. So I have 2 squared times 7. And then I have x squared, that's x to the fourth, x to the sixth, and x. So what's coming out of the radical? A 2, an x, an x, and an x. So 2x cubed outside the radical. Inside the radical is 7x. If I have multiplication, if you remember, I'm going to multiply what's outside the radicals together. And then I'm going to multiply what's inside the radicals together. Now I'm going to simplify. So I have the 21 outside. I'm going to break down 40. So I have 2 to the third times 5. I'm going to rewrite that as 2 squared times 2 times 5. And then I'm going to leave it as x squared. So out of the radical comes a 2 and an x. So I'm going to multiply the 2x with the 21. So that gives me 41x and then radical 10. All right, why don't you pause the video right now and try these next 3. I'm going to go ahead and jump into it. So I have 27 is 9 times 3, which is 3 times 3. So I've got the square root of 3 squared times 3 times n squared. So out comes a 3 and an n. So it's 3n radical 3. B, 60, I can break down into 4 times 15, which is 2 times 2, which is 3 times 5. So I've got 2 squared times 3 times 5. And then I have a squared times a squared times a squared times a. So 2 comes out, an a, an a, and an a. And now once again, I multiply this by that negative a. So negative 2a to the fourth times the square root of 15a. And then lastly, I've got x squared times y squared times y squared times y. So out, out, and out. So x, y squared, radical y. All right, so we're going to try some trickier ones. So looking on the left here, I'm actually able to simplify within the radical if I can. So if I think about 75 and 48, they're both divisible by 3. So if I divide them both by 3, I get 25 over 16. And then x to the 5th over x, I can subtract those exponents and get x to the 4th. And now I notice I actually have a perfect square. The square root of 25 is 5. The square root of 16 is 4. And the square root of x to the 4th is x squared. So it does pay to simplify first before you decide to try to do square roots or try to get rid of the radical on the bottom. So looking at this one over here on the right, I can't simplify anything. So well, I can, but I can't do what I did in the previous problem. So I'm going to rewrite it as radical 11 over radical, let's see, 12 I can write as 2 squared times 3. And then times x squared times x. So out of the radical comes a 2 and an x. And now I'm not allowed to have radicals in the denominator. So in order to rationalize the denominator, I'm going to multiply by that radical. So radical 3x over radical 3x. Remember, this is just a fancy version of 1 because anything divided by itself is 1. So now I have radical 33x over 2x times, when I do radical 3x times radical 3x, I'm just left with 3x. If that's a little quick for you, think about it this way. Radical 3x times radical 3x, I can multiply and get 9x squared under the radical. And if I square root that, I get back to 3x. The reason is, when I square radical 3x, the square root and the square undo each other. So my final answer is radical 33x over 6x squared. Remember, I can't simplify anything that's in a radical with something that's not in a radical. So this is just my final answer. All right, so now we have a bunch of problems I would like you to try. They're similar to what we did yesterday, but they're throwing on variables. So go ahead and give these a try. I'm going to jump in and start going over them, but I really would like you to play around with them and try them first before you watch me do them. So we have negative a, square root, we can break down 60. 4 times 15, which is 2 times 2. So I've got 2 squared times 3 times 5 times a squared times a squared times a squared times a. So out comes a 2, an a, an a, and an a. So negative 2a to the 4th radical 15a. The next one, I want to multiply radical 13 times radical 52. Well, I know I'm going to end up just multiplying them together, and then I have to actually factor them in order to simplify. So instead of multiplying them together, I'm actually going to take 52 and do its prime factorization because I don't want to have to use my calculator and pull it out. So 13 times 4 is how I can get 52. So under the radical here, I actually have 2 13s, so 13 squared, times 2 squared. Well, wait a minute here. They both come out of the radical. So I don't have anything left in the radical. I just have 26 outside. B, let's see, I've got 5, and now I've got 3 times 6 times c squared. So same thing. I could write 18 here. Or I could just say I'm starting with 3 times 6 and then factor the 6. So I've got 3 squared times 2 times c squared. And there's a 5 out in front. So out comes a 3, out comes the c. So 15c radical 2. The next one, I'm much better off simplifying first within the radical. So 27 divided by 3 is 9. X cubed divided by x is x squared. And now I go ahead and take the square root. That is a perfect square, so it's just 3x. 4a, remember I can't have a radical in the denominator, so multiply by radical 3 over radical 3. So I get 3 radical 3 over radical 3 times radical 3 is 3. And then I should notice that I can divide out the 3's. So my final answer is just radical 3. B, I've got, let's see, radical 5 over, I can simplify radical 18. So 18 is 9 times 2, which is 3 times 3. So 3 squared times 2 times t. So 3 comes out of the radical, and I have radical 5 over 3 radical 2t. So you should have multiplied by radical 2t over radical 2t. And that's going to give me 10t over 3. And now remember, when I multiply radical 2t times radical 2t, I'm going to get 2t. So radical 10t over 6t. Remember, I cannot simplify or divide out the radical 10t with the 6t because radical 10t is in the radical. It is radical 10t. It's not just 10t. So this is my final answer. All right, you have another bunch to do, so go ahead and give those a try. I'm going to go ahead and jump into it again, but like I said, you should practice them. So for 75, I'm going to multiply what's outside the radical and multiply what's inside the radical. So I've got 8 radical 6, and I should always do a check to see if I'm able to simplify. I know I can't because 6 is just 3 times 2. Next, same thing, multiply, so 42. Radical, this is 24. And can I simplify that? Yep. Because I have 8 and 3. Look, I'm back to that 8 and 3 again, right there. That's why it doesn't really make sense to multiply them. And then I've got 4 times 2, and then 2 times 2. So I've got 1, 2, 3 2's, and a 3. So 2 squared times 2 times radical 3. Out comes the 2. So I have 84 radical 6. 77, I'm just going to multiply by radical x over radical x, that fancy version of 1. So 10 radical x over x, and I'm done. 78, I'm going to multiply by that fancy version of 1, radical 2x over radical 2x. That gives me, oh, wait, pause. Did anyone notice that radical 9 is just 3? If you didn't, you should simplify it at the end. But if we catch that first, it just saves us some time. So I have 3 radical 2x over radical 2x times radical 2x is 2x. Oops. 79. I can simplify radical 20 first. So I have 4 over radical 2 squared times 5. So that's going to be 4 over 2 radical 5. Now I'm going to multiply by radical 5 over radical 5. So that gives me 4 radical 5 over 2 times. And when I do radical 5 times radical 5, I get 5. And then hopefully you noticed that you can still simplify the 4 and the 10 right here. They have a common factor of 2. So 2 radical 5 over 5. 80. I can put this whole thing under the radical, go in reverse to simplify first. That might make it a little easier. So divide out the x, and then I have a common factor of 3. So I have radical 4 over 9. So that's just 2/3 when I take the square root. Next, 81. Let's see, I've got 3 radical 7. I already did 20 back in problem 79. And I know that's 2 squared times 5 times x. So out comes a 2. So 3 radical 7 over 2 radical 5x. And now I'm going to multiply by that fancy version of 1 to rationalize the denominator. So I get 3 radical 35x over 2 times. And then remember, I multiply these together and I get the 5x. So I have 3 radical 35x over 10x. And I can't divide out that x because one is in the radical and 1 is not. 82. So I can simplify the radical 8 in the bottom. 8 is 2 cubed. So 2 squared times 2 times y, out comes a 2. So 4 radical 5 over 2 radical 2y. And if I want, I can simplify the 4 and the 2 right now. So 2 radical 5 over radical 2y. And now I'm going to rationalize the denominator by multiplying by that fancy version of 1. So I get 2 radical 10y on top over 2y. And then I'm able to divide out these 2's because they're both outside the radical. So radical 10y over y. I can't divide out this y and this y because one's in the radical and one is not. So this is my final answer. So your homework tonight is on Delta Math with those radicals. If you need to rewatch the video, you can. And I'll also have a copy of these notes on Schoology for you as well. All right, have a great day, everyone. Bye.